Morning, good evening, good afternoon, wherever you are. I'm Jackie Lynch, and the purpose of this presentation is to introduce you to some of the terminology surrounding the new HMCs. And we're going to cover things like what the BMC is, the VMI, the eBMC, and so on. Initially, we'll go over the terminology and what all these acronyms mean. Then we're going to talk about installing fixes. We'll talk a little about documentation. And we'll talk about redundant HMCs as well as remote HMCs. And then I have some comments on commands and backups. So the first item to talk about is the HMC, which stands for Hardware Management Console. And as of today, that can still be an x86. The 7042 is the model number. Or it can be power-based, like a 7063 CR1 or CR2, or it can be a virtual HMC, depending on what your needs are. The servers can run without an HMC, but if you want to do remote power on, power off, live partition mobility, or get a remote console, then you really need to have an HMC. And each HMC has one connection to what I call the public network or the administrative network. That's basically where you connect to it using HTTPS or SSH. And there is a second private connection that is connected to the flexible service processors or the eBMCs, which we'll explain later, on the attached servers. And that private connection can be a direct connect if there's only one server, or you do it via a private switch or VLAN. The private switch uses DHCP, so it's important that it's a private network that's non-routable because you don't want to be dropping DHCP packets on your public networks. The other thing to note, I mentioned that you could do the x86 HMCs like the 7042s. They cannot run any HMC code above version 9.2, and that's already out of support. So it really is time to transition to the new Power HMCs or to the virtual HMC. The other thing you should keep in mind is that if you have any Power 7 servers, then you should move everything else to one of the Power HMCs and keep the Power 7 on the x86 HMC. Otherwise, it will stop you updating your Power HMC from version 9 to version 10. And a lot of the new goodies are at version 10. So the new Power HMCs, which is the 7063 CR1s and CR2s, have something called a BMC, which stands for a Baseboard Management Controller. What's really nice about it is it lets you remotely control the HMC, and what that means is that when you're doing a reboot or an upgrade, you can connect to the BMC while the HMC itself is shutting down and coming up, and you can actually watch what's happening. It also lets you do things like attach an ISO image as a virtual media, and you could use that for updates. I've actually had to use the BMC when I did an upgrade to a remote HMC and it died, and I had to reinstall from the recovery ISO. Rather than fly to the location, I was able to load the ISO and I was able to use the BMC to get a console so that I could do the install. So on the HMC that is made from Power, we now have a public interface on ETH0, and the private goes on any one of ETH1, ETH2, or ETH3. This is different to the x86, and the reason that we put it on ETH0 for the public interface is now the BMC does not have to have its own physical connection. It can share the port with that public connection, and it has an IP on the public network. This will save you on cables and switch ports. So both the HMC public interface and the BMC interface require an IP address on the same subnet. You can access the BMC just like the HMC using SSH or HTTPS. Additionally, that BMC is maintained separately to the HMC code. So think of it as the difference between the firmware that you put on your server and the operating systems you put on the server. So the BMC is a different piece of code, and you'll hear people talk about BMCs and PNORs, and those are basically the code that you put on, which is really like the firmware for the HMC. And they are different between the CR1 and the CR2 models, so you need to make sure you download the correct ones. And we'll talk about how to apply those later. Now, the first time we log into the BMC, the username is root and the password is 0PENBMC, and it will force you to change the password. As soon as you get logged in the first time, I highly recommend you add a second admin account, and I always add a BMC cred one, which is for the credentials between the BMC and the HMC. When I configure the BMC from the HMC, I set it to shared mode on ETH0. That allows the BMC to share the same physical connection that the HMC has, and I give it a static IP because it's on my public network. On the CR2, you can't do this immediately. You have to make sure that you're at version 10 of the HMC code first. Then it provides you with that option and lets you edit it. You'll also find that there's reference to something called BMC in-band credentials. So the HMC has to be able to talk to the BMC to monitor for problem reporting and for a bunch of other tasks. In order to do that, you have to set up an in-band interface so the HMC can talk to the BMC. And this is what they mean by in-band credentials. So I normally create a BMC cred account on both the HMC and BMC, and that's what I use for the in-band credentials. I highly recommend becoming familiar with the BMC on your Power HMC. It has some incredibly useful features. It lets you load recovery ISO images and other ISOs to it using virtual media. It lets you get remote control to the remote console. It also allows you to apply the firmware for the HMC, and that's what I was talking about with BMC and PNOR. It lets you monitor the health, and it lets you add users and a bunch of other things. So if you look at this diagram below, you'll see the firmware revision is 3.26. This is a CR1, and 3.26 is the BMC level. Then the PNOR build time is 2020-0610, which I happen to know is 3.11 of the PNOR, which is still the current. It's important to know what these are because the HMC scanner doesn't show them to you, and nor do any of the LSHMC commands. And in this slide, I'm just showing you some of the things where you can see the virtual media interface. You can see that you can load a CD-ROM image and how to load it. And then there's a bunch of maintenance options for your BMC and PNOR update. Now again, this is from a CR1 HMC. So prior to Power 10, you would have heard engineers talking about the FSP, or Flexible Service Processor. And that's the port for those servers, usually labeled HMC1 and HMC2 on the server, that the HMC connects to on the private network. The HMC, as I said earlier, uses DHCP on this network, although you can use static to provide an IP to the FSP from a range you select, and it uses it to manage the servers. To add to the confusion, the documentation often refers to HMC1 and HMC2 as ETH0 and ETH1. The most important thing is these are the HMC ports on the servers, and then once we get to Power 10, we no longer have an FSP, we have something called an eBMC that I will talk about in a little bit. So you can see the red arrow, and that's actually pointing to the two HMC ports for the FSP. So the eBMC is really the replacement for the FSP, and it stands for Enterprise Baseboard Management Controller, and it's used in the Power 10 servers. Additionally, it introduces a new connection type between the HMC and the managed server, and that interface is called the VMI. This means you need an IP address for the FSP, or in this case eBMC, and an IP address for the new VMI. Both those IP addresses are on your private network, and I normally set them both to DHCP. Just like with FSP-based systems, there are two Ethernet ports that can be used to connect to redundant HMCs. They're referred to as HMC 1 and 2, or ETH0 and 1. Each HMC is going to be cabled to one eBMC port and will require two IP addresses on that private network. So if you have redundant HMCs, we're talking about 4 IPs. And then the eBMC IP address becomes active once the server's completed power supply initialization. So this diagram is just showing you the rear view of an E1050, and you can see that the eBMC ports are over in the very, very first slot, and there are 2 of them. And then this is just showing you the same thing on an S1024, and you can see that the eBMC slots are actually in the middle in port C5. Now the ASMI, or Advanced System Management Interface, is basically the graphical interface to the eBMC or FSP. And that's used to read service processor logs, vital product data, to take dumps, to control system power, and to do a number of other connections. For Power 10, the default username and password are admin, and you should obviously change that. In fact, during your first login, you are forced to change it. I highly recommend that you record it somewhere, because otherwise, if you have to log into the FSP through the ASMI, you're going to have to find that password and call IBM if necessary to get them to give you a workaround. For all of these users, I actually always create myself an additional admin account so that if something happens to the base admin account, I can still log in. I do it for the BMC, I do it for the ASMI, and it's something that you should consider as well. So the eBMC is basically the replacement for the service processor. And the piece that's really new with Power 10 is this new interface called the VMI, or Virtualization Management Interface. This resides in the Power Hypervisor on the Power 10, and again, as I said earlier, it has an IP on the private network of the HMC. This is the IP that HMC is going to use to talk to the hypervisor when it wants to manage partitions, when it wants to do console work, and so on. As a user, you never interact with that IP. The only thing that you really notice is that there are now two IPs on that private service network rather than one. And there are ways to actually see what the IP is that did end up getting assigned, which we'll talk about later. So there's now two endpoints that the HMC talks to, the eBMC and the VMI. All of the traffic between the HMC and VMI is encrypted. And as I said, the VMI will support both DHCP and static IP. I tend to change it to DHCP. And again, VMI shares the same physical connection as the eBMC going to the HMC, so there's no additional cabling. This is the diagram that I got from the IBM community. And as you can see, what it's showing you is just a diagram of the difference between an FSP and an eBMC in terms of connectivity. And you can see the primary difference on the bottom right diagram is that the HMC talks to the eBMC, but it also talks to this VMI that's part of the Power Hypervisor. And I highly recommend going to the link that I have there, where Hari Ganesh talks about what's new in the Power 10 and the HMC. So when you're setting up the VMI, as I mentioned, it's actually on the private network. There's a couple of things that I found very confusing. So when you're configuring the VMI, it uses the terms ETH0 and ETH1, which refers to the HMC 1 and 2 ports on the eBMC. It is not referring to the ports on the HMC. You configure the VMI on the HMC typically under Actions, View All Actions, Operations, VMI Configuration. But it may look a little bit different depending on what level of the HMC code you're running. You can list all the interfaces for just VMI using the ls-syscon-r VMI, or you can just show all interfaces including the VMI with the ls-syscon-r space all. As I mentioned earlier, the VMI should be configured before you power on the system, otherwise the system will go into a no connection state when it reaches standby, and then you have to actually recover from that. There's a very good article by Hari Ganesh on what's new in HMC 10.1.10 20.0, and there's some great diagrams there. Additionally, Sean Bodley posted a blog on his experiences with installing a Power 10, and there's another article that I highly recommend on managing Power 10 scale-out and mid-range systems. There are also a number of videos that IBM has provided on the VMI and Power 10 setup. So initially when the server comes up, it's going to get added to the HMC with a name of BMC-000-BMC- and then the IP address it was assigned. And it will be in a pending authentication state waiting for password updates. So you go ahead, you authenticate it, and now the server name will change and you'll get the actual server. With the eBMC, you no longer have the old HMC access ID. The only ID you have is admin, and as I said, it has a default password of admin. That password is expired and you will be required to change it. So you no longer have general and HMC access. For the ASMI, you will actually log in as admin with the password that you set. So make sure, as I mentioned earlier, to save that password. This is the point at which the server name will change to actually include the server name and serial number. You should now be able to launch the ASMI to check that you can log in. And like I said, I normally add an admin user for myself. At this point, the server is in a power off state. You go back to the GUI, you configure the VMI, which is typically under Actions VMI configuration. And I usually use ETH0 set up to DHCP. If you power on before configuring the VMI, the server will come up in a no connection state once it's in standby because the HMC expects to talk to the VMI. So you could be connected to the eBMC but not to the VMI or hypervisor. And if that happens, you go to Actions, configure the VMI, and it should then finally drop into standby mode. So this is an example of some VMI setup for my 41B. You can see that when I look at the VMI configuration, it's showing me that ETH0 is set to 192.168.240.10, and it's got the subnet mask, etc. This one's currently set to static. Someone else set this up, but you can set it to DHCP. If I run the ls-syscon against the server, and normally you would have to put the proper serial number in, I've replaced that with X's right now. You can see that ETH1 has no IP and is not connected, and then you can see that ETH0 has an IP assigned to it. You can see the same kind of information when you do an ls-syscon-r all. It actually gives you the VMI state connected and what the VMI IP address is. And this is an example from the 22A that I set up. As you can see, it's configured on ETH1 for some reason, and I've got it set to DHCP. And you can see it got assigned an IP address, and again you can see the output from all the ls-syscon commands. And this diagram is just showing you again what it looks like from a diagrammatic point of view. You can see that ETH0 on the HMC is connected to the public network. ETH1 on the HMC, which has an IP of 10.0.0.1, is using DHCP, and it's actually connecting down to ETH0 on the eBMC, and the VMI is using that ETH0, and it's also been assigned a DHCP IP address. So in the next couple of slides, I just want to show you some of the connectivity differences between the various HMCs. So if you've still got Power 7s, you've probably got a 7042 CR9 x86 HMC. And when you look at it, you have ETH0, ETH1, ETH2, ETH3. They're basically these four connectors in the middle, going left to right. Now the 7063 CR1, which is the first of the Power HMCs, has a block of 4 Ethernet connections. ETH0 is the bottom left, ETH1 is the bottom right, ETH2 is top left, ETH3 is top right. And again, as I said earlier, we use ETH0 for the public or admin network and any of the other 3 for the private network. When you look at the 7063 CR2, it has a block of 4 horizontally on the left, and then there's a single one that you can use. So the single one is if you want to have a dedicated port for your BMC. As I said, I tend to put my public network on ETH0, and I configure my BMC to share that port so that I don't have to add extra cables and extra switch ports. And I have the link here to the red book that actually goes into this in detail. So as I mentioned earlier, there are now multiple IP addresses in setting up your HMC with a Power 10. So if I look at ETH0 on my HMC, which is what I call the public or admin network, I have an IP for my HMC and an IP for the BMC. That's the BMC on the HMC. That is not the eBMC on the server. Then either ETH1, 2, or 3 is where I put my DHCP range, and there will be an IP assigned to the eBMC, or if it's a pre-Power 10, it'll be an FSP. And then for a Power 10, there will also be an IP assigned to the VMI. And if you have redundant HMCs, there will be a second set of IP addresses. And so altogether there would be 8. This is something you need to keep in mind if you're short of IP addresses on your public or administrative network. Links below are to a number of other useful articles that have been published, and also to the videos that I referred to before. Russell Young from IBM Engineering has published a number of little videos that actually take you through a lot of these steps. So we've been going into the terminology. Now we're going to move on and we're going to talk about putting fixes on your HMC. So step 1 is always to go to the Fix Level Recommendation tool, or FLIRT, and check all your prereqs. Plug in all the levels that you're at and see what it tells you need to go to. You can also use FLIRT Lite and just do some simple checks. From FLIRT Lite you can also tell when the end of service pack support is for any level, so you can figure out if you're going to be supported or not. You'll also find things like the AIX support lifecycle, the power code matrix. There's a bunch of system software maps. Now when you go to download fixes, updates to the HMC are found at Fix Central, and you'll find them under Management Consoles. The BMC and PNOR updates that I mentioned earlier are also found at Fix Central, but you actually look for them under Power, which is where you normally look for firmware, and you scroll all the way down to the bottom, and that's where you'll find the BMC and PNOR updates. So this is an example from a while back for a FLIRT report for one of my HMCs, which is the CR2. Now FLIRT doesn't talk about the PNOR and the BMC, so that's something that you have to double check yourself. So this report, the HMC was at version 10, release 1, M1011, and it went out of support in July 2022, and then they've recommended updates and fixes. Now since then things have changed, and the latest version is HMC version 10, release 2, M1060, sorry, actually version 10, release 3, M1060, and there's a patch to go on that, which is MF70704. So just keep that in mind, but the Fixed Level Recommendation tool will tell you all of that. I also want to make a note that the HMC scanner, which I use extensively to document systems, does not report on the BMC and PNOR, and it does not show the VMI IPs. So the BMC and PNOR updates are at Fix Central, as I said, under Power, and you scroll all the way down and select the specific HMC. So that's what the diagram to the right is showing you. As of today, which is September 8th, the latest levels for the CR1 are 3.11 of the PNOR and 3.28 of the BMC. For the CR2, it's what's called OP940.71, and you see the PNOR and BMC levels there. They look quite different. Before applying these, always read the README or the description that is provided by Fix Central, and make sure that everything that you currently have meets the prereqs, whether it's an HMC version or a server firmware version, and so on. So in order to update my BMC on the 7063 CR1, because I have a separate IP for the BMC, I get to it via the web using HTTPS. I download the fixes to my desktop. I then go to the BMC, select maintenance, select BMC update, and I enter update mode. I then go down and I select the .bin file, which is the BMC code from my desktop, upload it, and it will then show me the existing and new versions, and then I go ahead and I start upgrade, and at the end of it, it will completely restart the system. After the restart, you can confirm the level that's installed by looking at the dashboard. Once you've updated the BMC, then you go ahead and update the PNOR. And you're more likely to have BMC updates than PNOR, although sometimes you get both. So again, you go to the BMC on the web, select maintenance, select PNOR update, and enter update mode, and then you choose the file that ends .PNOR. And you upload it, and again, click Start Upgrade, and then when it's complete, it's going to restart the system, and then again you can confirm the level on the dashboard. So on the dashboard, you'll see firmware revision and PNOR build time, and those are the two things that will change. And I've just also got down here what the maintenance screen looks like, so you can see BMC update and PNOR update. This will look completely different on the CR2. So on the CR2, you can see the output here of the LSHMC-B, and you see this thing called Mowgli IBM OP9 v2.5.4.115, and then you see OP940.HMC-5.0. So they have very different names. And we're going to make sure that we get those from IBM, get the ones for the CR2, and then we will install them in the correct order. So on the CR2, we're going to access server configuration and firmware on the BMC. We'll then scroll down to locate the section to upload the firmware image. It looks completely different from the CR1. You're going to choose a file and you're going to look for your BMC image. Your BMC image is the one that has Mowgli and ends.tar. You'll upload it, and then when it's uploaded, you'll get a confirmation message, and basically it's ready to go on. You go and click activate under the action column to activate it, and it will go ahead and it will install the BMC update. After you reboot the BMC, you'll then go ahead and put on the PNOR, and that's also known as the server image. So you scroll down again to upload the firmware image, you choose the file, and in this case, it's going to be the one that says something like version 2.5.4. I believe the latest is 134, and it has PNOR in the name at ends.tar. So you'll upload it. Again, when it's ready, you'll activate it, and then it should reboot the BMC. And when it's done, you can check by looking at the dashboard. You can use the command line like LSHMC-V, LSHMC-B, and --BMC, but they don't give you everything. They just give you the BMC information, not the PNOR information. So the dashboard with server overview is the one place you can see both your PNOR and your BMC levels. And that's what you're looking at here, is these two firmware versions. That's actually telling you what the levels are that you're currently running. Now we're going to talk about how you install HMC fixes. And you basically get the code from Fix Central. You can use FTP or FTP-S to go get the patches, or you can download them to your desktop and upload them to a local server. I personally put all my updates on my NIM server, and that's where I store all my software. That way I know that the server is up when I want to put my patches on. Plus, additionally, it's usually faster across my local network. The fixes are in multiple locations depending what kind they are. If you're having to do a big upgrade, like going to ML1050, then you basically need to go to the HMC network v1050/PPC if it's a PowerPC, or .x86 if you're using one of the virtual HMCs. That's where you get those files, and that's anything that's used by the get upgrade files command. Those are the ones that you can't do through the GUI. If it's just a patch or a level update, then you could do those through the GUI, or you can use the update HMC command. So regular patches, like the latest fix for ML1060, you get from the HMC fixes directory, and it'll be an ISO image. Updates, which are bigger, more like a service pack, you get from the updates directory. And if you have to reinstall or do an actual initial installation, you can use the HMC recovery directory and grab that ISO. And the diagram that I've got there is showing you what you would expect to see in the network directory if you were doing get upgrade files and you wanted to look at doing this across the network. So there's a specific process you need to follow for doing HMC patching. The first thing is reading the README and description files. They are critical. They will have comments in there, just like you would find in firmware, about certain things have to be at certain levels in order to work with them. So you want to make sure you read that and make sure that, for instance, if you're putting on a version 10, that you don't have any Power 7 servers connected because they won't be supported. Upgrades are also typically a multi-step process and you can't skip a step. So before I make the change, I normally will run an HMC scanner report. I back up all the profiles. I do my save upgrade data. I back up the console data, either to USB or usually to my NIM server. And I get the output from LSHMC-V and -V. Then depending on the update step, if you're doing a major change that requires get upgrade files, and if you're using .ISO images, like the little patch or the service pack, then it's going to be UPD HMC. One of the things you always have to remember is the last thing you should do before you start the upgrade is run save upgrade data -r space disk. The HMC patching is very sensitive to that, and if you don't do it, you can end up doing bad things to your HMC. And then when you're done, get another HMC scanner report, get the output of the LSHMC commands, and back up your HMC again. The other piece that you need to update is your eBMC or your server firmware. And typically the process is that you'll need to get the firmware. I usually load it to my NIM server, unless I'm updating the firmware on my NIM server. And you're going to get the tar file and the XML file for the Power 10, and then you'll just go through update firmware, system firmware, update. When you find the code, make sure you use the tar file, not the RPM file. You can do it from the HMC GUI. You can also check the current server and firmware levels under that firmware tab on the HMC. There is also a way to do it using SSH. I don't tend to do that. I find that the GUI is actually a little bit safer. The one thing I would note is that quite often it will tell you that it's not a disruptive update, and then afterwards you find out that you have some deferred updates. So I typically, when I do a firmware update, I plan time to power off the server and power it back on, even if it says to me that it's going to be concurrent. So just something to think about. You don't have to do it, but it's something I would keep in my back pocket, and I would always plan for that amount of time, even if I'm not going to use it. Anyone that knows me knows that I'm a big fan of documentation, and in fact I do what I call pre-documentation. When I'm doing an upgrade, I actually record everything I'm planning to do ahead of time, and then I update it as I go. That way I have a really good plan ahead of time, and I also have all my backouts and everything else in that document. So what kind of things do I use for documentation? Well, I've talked about the HMC scanner. I also sometimes use the system planning tool. Both of those can be downloaded from IBM. And then I put together a spreadsheet of documentation. In it, I have all the equipment and serial numbers. I may record in there the ASMI and other critical passwords, or I may record them in a separate document that is encrypted. I keep track of the UAK, which is the Universal Access Key expiration dates for the firmware and the AIX. I have customer numbers in there, server and IO firmware levels, VIO server and operating system levels. I record information about the HMC, like the version, BMC, PNOR, what the networking looks like, any IP addresses, adapter allocations. I have a set of standards that I develop for each server for what I'm going to use for the numbers, for the adapters, for the network vSCSI and MPIV mappings. I'll assign a group of them to VIO1 and a group of them to VIO2, and I keep track of the actual assignments for the vSCSIs and the MPIVs. I also like to document the VFC hosts and all of their WWPNs so that it makes it much easier when I have to request zoning changes. And of course, information on the shared Ethernet adapters and virtual Ethernets. The power needs, I do PDU mapping to make sure nobody breaks the rules for power. Pretty much anything that you think is important, that's stuff that should be in your documentation, because you don't want to be the person that has a major outage and realizes you have to completely rebuild the server and you have no documentation. These are the links for information on the HMC scanner and where to download it. As of September 8th, the latest version is 0.11.54. and it does a really nice job of documenting your HMC, your pools, capacity on demand, your LPARs, all of your profiles, your WWPNs, all that kind of thing. You still need to separately document your BMC and PNOR levels and IP, and your VMI IP, and of course those usernames and passwords. I also noticed that since version 10, when I run the HMC scanner, you notice under fixes here, it's actually blank. It used to actually put all the fixes there. So that's why the LSHMC-V is actually useful, because as you can see here, it's telling me I'm on version 10.2.1031 with patch 70729 applied. But the piece to the left, which is from the HMC scanner, does not show that that patch is on. A lot of customers like to run redundant HMCs, so we're going to talk a little bit about redundant HMCs and setting them up. As I mentioned earlier, a power system can be managed by one or two HMCs. The two HMCs are peers, and they can manage any servers they see. One thing to note is they must be at the same code level. Don't upgrade one and wait a week to upgrade the other. They should be kept at the same code level as close as possible, just like with VIOS servers. You need two IP addresses for each HMC, one for the HMC, one for the BMC, and then you're going to need two different private ranges. Each HMC must have a different private range. They can be on the same public or administrative network for you to access them, but that private range that goes to the eBMC or the FSP needs to be a different one for each HMC. And there's a link in here to IBM's support page on configuring redundant HMCs. In terms of users, unless you're using LDAP, you'll need to add users to each HMC. It does not automatically copy them between HMCs for you. So this is an example of a redundant HMC setup, and you can see that the HMC that's in red is using one private IP range, and it actually happens to be on a different management network, but it doesn't have to be. It's connected to the FSP1 HMC port 1 and FSP2 HMC port 1 on each server. And then the other HMC, which is the purple one, is connected to port 2. I like to make sure that when I'm doing redundant HMCs that I use the same eBMC or FSP port for each connection for one HMC, and then the same port, like you see here, port 1 for the red, port 2 for the purple. It just makes things a little simpler and less complicated. And this is just a much more simple diagram showing you what the connectivity looks like, where you're going through the network, and this is the private network, through the switch to the HMC. Another option you have is to have remote HMCs. So you can have your local HMC and then have one that's set up remotely. And there's a very good article on this that I've given you the link to. So I've used this when I was migrating between servers. And we set up remote HMC trust. That's the first step, which involves setting up SSH keys between the two HMCs. So the first thing you have to do is you have to create a user ID to use for LPM. I created an account called LPM account because I want it to be obvious. And then you have to create the keys, which is the make auth keys step. You do this on both HMCs, and then you log in as LPM account and do the same thing with the make auth keys again. So basically you go through these steps so that you end up with the right keys between the two servers so that you can actually do commands and not have to log in. So this lets you do remote LPM between two HMCs with either one being able to be the source HMC. So setting up remote HMCs is a little bit more complicated than what I talked about, but the article that I gave you the link to should cover everything that you need to know. The other thing I want to talk about is just to go over a few of the HMC commands that you may find useful. So this is a list of some of the HMC commands that I use a lot. The lssysconfig that gets me all the configuration information. The lssysconfig with the OS refresh I usually use after I do a bunch of AIX or VIO server upgrades. that tells the HMC to go out to that system and make sure it really does update itself with respect to what the operating system levels are. Normally it does it automatically, but I have noticed sometimes it doesn't, so this is a very useful command. And then we have the ls-syscon-r all and the -r VMI, depending on what you're looking for. The dash lowercase v and capital V get you information on versions, etc., and the lowercase v will get you the actual HMC model and serial number. The -b and -BMC will get you BMC information, but again not PNOR. And the -n gets you network information, and who-b will tell you when it was last rebooted. I'm not going to go into these, but this is good for your documentation. This is all the flags on the ls-HMC command that you can use to figure out how your system is set up. I am also a big fan of backups, and I like to take backups regularly. So the next couple of slides we're going to talk about backups. So there are a number of backups that you can do for the HMC. On the HMC, you will have all of the LPARs, and each one of those has a profile associated with it. So what you can do with the server is you can tell it to back up the profile data for the server, and that will get all the information about the LPARs, how they're configured, what goes where. So before I do any upgrades, I do a backup profile data, and you have to give it a unique name, so I usually just put the date in the name. And I've given you the link to the command for the backprof data. Then I usually do a save upgrade data -r disk, and I may also do a save upgrade data -r disk FTP and copy that information to my NIM server. And I've given you the documentation link for that. And then my last step is to do a back cons data. This is basically going to back up your HMC. So I'll normally back it up remotely, or I'll back it up to a USB, or both. And again, I have the link there. And the options you can use for the -r are USB, FTP, SFTP, or NFS. And just take a note that at this point, you're then possibly going to go do an upgrade. The last step that you should take before you do any upgrade is a save upgrade data -r space disk. You can never do too many of them. Although HMC 950 is out of service, I wanted to point you to this link to this article because it talks about a lot of the new features that came out in HMC 950. And actually, the latest is version 1060, not 1040. But none of these support Power 7 or 7 Plus servers in any way, shape, or form. Two articles mentioned here go into some of the details of what is new in HMC version 10. And one of those things is the ability to validate and prepare your VIOS server for maintenance. It will actually go out and it will check that the storage and networking provided by the VIOS servers to the client partitions is correct. And that means that it will check that you've actually zoned and mapped all the storage so that you can do an LPM. You do not want to do an LPM if the storage has not been correctly provisioned, as you run the risk of corrupting your boot image. So with the latest versions of the HMC, you can now back up your VIOS server virtuals and the actual VIOS server to the HMC, and you can restore from there. That could be very useful. You can also import and export those backups to and from like a NIM server, whatever it is that you like to use. And you can do this through the GUI, or you can use the command line commands. There's 3 new flags on backup iOS. One is the -makesysb, and that creates a pure makesysb resource that can be used to restore the VIOS server from your NIM server. You can also create a backup that has what's called a NIMOL resource, which is a tar file, and that's used to restore the VIOS server from the HMC. The -no media flag file tells the system not to back up the media library. That's important if you actually have your media library in root VG. I normally do not have it in root VG because it makes my root VG image just really, really big. And then the last one is the no SVG, which stops the volume group structures for any user-defined volume groups in that VIOS server from being backed up as part of the backup iOS process. I do recommend that you're very careful because there's not a lot of free space on the HMC for these backups. I think my HMC has about 15 gig that can be used for these images. So it's useful, but just be a little bit careful. So the commands that are listed on this page are the command line interface on version 10 for doing HMC backups for your VIO. So you can see you can list the backups, you can create an IO config backup or an actual VIO backup. You can rename them, you can copy them to a remote server, and you can restore from them. So again, I would make sure that you're familiar with these commands, or at least have downloaded the docs in case you ever need them. So this slide is showing you the level that my HMC is at, and I check that to make sure I can use the CLI commands to control my images. So I'm at version 10 release 3 service pack 1060, and I have the very latest patch MF71704 installed. Commands on this page are the ones that are provided at version 10 that let me manage my VIO server install images. So I can list the images, I can list them by a specific name, I can change them and give them new names, I can delete them, I can copy them. You can see here that I'm doing an SFTP and I'm copying my VIO server image to my account on a specific server. And the very last thing is actually showing you when I do an ls VIOS image, it's showing me that I have a VIO server 31321 image loaded and how big it is, so about 4.7 gig. So keep that in mind when you want to put VIO server install images on your HMC. Now keep in mind, this is the install image, this is not the backup. The backup was on the previous slides. And the images on this page are just showing you some of the outputs from the commands, showing me the name of my VIO server images and the output from the commands. Some of the other things you can do with the HMC, when you're doing HMC updates, you may want to turn off call home. Otherwise, you end up getting a whole bunch of calls from IBM because the HMC likes to tell them that it's getting an upgrade, but it does it in a really weird way. And then you could turn it back on when you're done. I always forget to do it, so I always end up with cases opened and I have to log in and close them. There's also documentation on the VIO server backup to the HMC and on the HMC maintenance validation for LPM. The other links I have here are information on the Power 10. I actually wrote an article on the topic of this presentation and I've given you the link to that. And then I've also given you the link to an article by Sean Bodley, which he wrote on Power 10 and the VMI and all the lessons that he's learned. So I'd really like to thank you for your time and for listening to this presentation. You can download a copy of the PDF of the presentation at the link that I've given you on this page. I also recommend that you join the Power Systems virtual group because they have a lot of really good presentations on these topics. And I have a bunch of other articles available through Tech Channel if you'd like to go and read them. This page is just a number of useful links to articles and YouTube channels and so on that you may find helpful. This is where you'll find a lot of the IBM websites for downloading software, the HMC scanner, inventory services, the fixed level recommendation tool, and so on. And there's also a link at the bottom to the Power best practices. Finally, these are the links on doing VIO server backups to the HMC, the announcement for the CR1 HMC, and some information on the CR2 HMCs. I hope you found this presentation useful, and I wish you all the luck with your new HMCs.